NVIDIA. Today, you would be hard-pressed to find a company more important to the modern technology world. Its chips are inside the data centers training artificial intelligence. Its software is used by researchers, engineers, startups, and some of the biggest companies on Earth. Its CEO walks onto stages in a black leather jacket and announces new products almost like a rock star launching a world tour. And in just a few years, NVIDIA went from being known mostly by gamers to becoming one of the most valuable companies in history. But what makes this story so fascinating is that NVIDIA was not supposed to become the company powering artificial intelligence. It started as a graphics chip company. And before it became a trillion-dollar giant, before the AI boom, before ChatGPT, before every major tech company started fighting for NVIDIA GPUs, the entire company nearly died because it made the wrong bet. This is the story of Jensen Huang, the immigrant engineer who built NVIDIA, almost lost it, and then spent decades preparing for a future that most people did not yet believe in. Our story begins in 1963 in Taiwan, where Jensen Huang, later known as Jensen Huang, was born. He was not born into Silicon Valley. He did not grow up surrounded by venture capitalists, startup founders, or the culture of American technology. His early childhood was spent in Taiwan and Thailand at a time when Southeast Asia was unstable and the Vietnam War had made many families deeply uncertain about the future. Jensen's parents wanted something safer for their children, so when Jensen was still a boy, they made a difficult decision. They sent him and his older brother to the United States. To a child, this might have sounded like the beginning of a new opportunity, but in reality, it was the beginning of a brutally difficult chapter. Jensen and his brother were sent to live with relatives in America, and through a misunderstanding, they were enrolled at the Oneida Baptist Institute in Kentucky. Their family believed it was a normal boarding school, but it was not the kind of polished, elite school they had imagined. It was a strict religious institution that, at the time, had students with very difficult backgrounds. Jensen was only a child. He barely spoke English. He was far away from his parents, far away from the world he knew, and suddenly living in a place where he had to grow up very quickly. At Oneida, students worked. Jensen cleaned bathrooms. His brother worked on a tobacco farm. And while many people later looked at Jensen Huang and saw a billionaire CEO, this was one of the most important parts of his origin story. Before he built one of the most advanced technology companies on Earth, he learned what it felt like to be the youngest, smallest, most foreign person in the room. He was bullied. He struggled with the language. He had to adapt. And for many people, a childhood like that could have created resentment. But for Jensen, it seems to have created something else: endurance. Later in life, when people asked him about hardship, he did not describe it as something to avoid at all costs. In fact, he often spoke as if struggle was the thing that shaped him. He learned that no work was beneath him. Cleaning toilets, washing dishes, waiting tables, engineering chips, leading a company. To him, the lesson was the same: do the work. Eventually, Jensen reunited with his parents in Oregon, and there, his life began to take a more recognizable shape. He attended Aloha High School near Portland. He was academically strong, graduated young, and became a serious table tennis player. But perhaps most importantly, he encountered computers at the right moment. In the late 1970s, personal computers were still new, strange, and exciting. Most people did not yet understand what they would become. But for a young Jensen Huang, the computer was not just a machine, it was a world of possibility. He learned programming, he played with early software, and he began moving toward the field that would define the rest of his life: electrical engineering. After high school, Jensen went to Oregon State University, where he studied electrical engineering. It was also where he met Lori Mills, who would later become his wife. But even here, the story does not become glamorous. Jensen worked, he studied, he built himself through discipline, not status. One of his early jobs was at Denny's, the American diner chain. He worked as a dishwasher, busboy, and waiter. At the time, this probably seemed like just another student job, but years later, Denny's would become part of NVIDIA mythology because the company itself would be planned in a Denny's booth. After Oregon State, Jensen moved deeper into the semiconductor world. He worked at AMD, then at LSI Logic, and while working, he earned a master's degree in electrical engineering from Stanford University. This part of the story matters because Jensen Huang was not simply a business person who hired engineers. He was an engineer. He understood chips, computing architecture, product cycles, and the brutal economics of hardware. And the hardware business is very different from the software business. In softwares, a small team can build, release, fix, and improve quickly. But in semiconductors, a mistake can cost years. You design a chip, send it to manufacturing, wait, test it, and only then find out whether the bet was right. If the market changes before the chip arrives, you can be dead before you even get a second chance. Jensen learned this world before starting NVIDIA, and that knowledge would become both his advantage and his curse. In 1993, Jensen Huang joined forces with two other engineers, Chris Malachowski and Curtis Preem. Their idea was based on a simple but powerful belief: computers were going to become more visual. At the time, the personal computer was already becoming important, but graphics were still primitive. If computers were going to handle richer games, multimedia, 3D environments, and eventually more immersive experiences, they would need specialized chips designed for visual computing. That was the opportunity. So the three founders started meeting at a Denny's restaurant in San Jose, not in a glass office, not in a luxury conference room, a diner. There, over coffee and food, they began planning the company that would become NVIDIA. The company's name came from the idea of NVIDIA, the Latin word connected to envy. The message was clear: they wanted to build technology that would make competitors jealous. But ambition is easy at the beginning. Survival is what tests a company. NVIDIA's first major product was the NV1, and the NV1 was not just a graphics chip. It was an ambitious multimedia chip with graphics, audio, and other features. On paper, it seemed bold. In reality, it was built around the wrong technical bet. The graphics industry was moving toward rendering 3D images using triangles. NVIDIA had bet on a different approach using quadrilaterals. That may sound like a small technical detail, but in the chip business, small technical details can decide the fate of an entire company. Game developers in the broader industry were moving one way, NVIDIA had moved another, and suddenly its technology looked out of step with the market. The company was in trouble. NVIDIA had also been working with Sega, the video game company, on technology for a future console. But when it became clear that NVIDIA's approach was not the right one, the project fell apart. For a young startup, this could have been fatal. And this is where one of the most important moments in NVIDIA's history happened. Sega could have simply walked away. Instead, Sega executive Shoichiro Irimajiri helped keep NVIDIA alive with a $5 million lifeline. That money did not make NVIDIA successful. It did something more basic and more important. It bought the company time. And time was exactly what Jensen Huang needed. NVIDIA laid off a large portion of its employees. The dream had become a survival exercise. The company had to stop trying to defend the wrong idea and instead build something that matched where the industry was actually going. This is one of the most important lessons in Jensen Huang's story. He was stubborn about the mission, but not stubborn about the mistake. The mission was accelerated computing. The mission was visual computing. The mission was to build processors that could do what general-purpose CPUs could not. But the specific implementation had failed, and Jensen had to accept that quickly enough to save the company. So NVIDIA pivoted. The result was the Rival E128. Released in 1997, the Rival B128 was the product that changed NVIDIA's direction. It was a 2D and 3D graphics accelerator that fit the market far better than the NV1. More importantly, it arrived at a moment when PC gaming and 3D graphics were exploding. But even then, the company was barely alive. NVIDIA was reportedly down to roughly 1 month of payroll when the Arav 128 launched. That is not a comfortable startup story. That is not a founder pretending to be poor while sitting on millions in funding. That is a company standing at the edge. And then the product worked. The Riva 128 sold rapidly and gave NVIDIA the oxygen it needed. After that came the Riva TNT, then more graphics products, and then in 1999, one of NVIDIA's defining moments, the GeForce 256. NVIDIA marketed the GeForce 256 as the world's first GPU, graphics processing unit. That term, GPU, seems obvious today, but at the time it was a positioning move. NVIDIA was saying that graphics were no longer just a feature of the PC. Graphics needed their own processor. In other words, Jensen Huang was not just selling a chip, he was creating a category. That category would make NVIDIA famous among gamers. It would make the company one of the key players in PC graphics, and it would give NVIDIA the identity it needed for the next stage of the story. In 1999, NVIDIA went public. Now the company had survived the near-death moment. It had found its market, and as gaming grew, NVIDIA became one of the companies pushing the industry forward. But the graphics card industry was still brutal. Competitors came and went. Product cycles were unforgiving. A delay of a few months could damage a company. A bad architecture could erase years of progress. Gamers wanted more performance, developers wanted more flexibility, and Microsoft's DirectX standards kept pushing the industry forward. NVIDIA survived because it built a culture around speed, technical excellence, and urgency. Inside the company, there was an unofficial idea that NVIDIA was always 30 days from going out of business. Even after success, Jensen Huang kept that fear alive. Not because the company was literally about to die every month, but because he wanted the organization to remember what it felt like when that had almost been true. This paranoia became part of NVIDIA's operating system. The company could not relax. It could not miss the next transition. It could not assume that success in one generation of chips guaranteed success in the next. And then, in the 2000s, NVIDIA began making a bet that looked strange to many people. Until then, GPUs were mainly understood as graphics chips. They were for games, animation, visualization, and pixels. But Jensen Huang believed that the GPU was not only useful for graphics. At its core, a GPU was a parallel computing machine. A CPU is designed to handle a wide variety of tasks, but a GPU is designed to perform many operations at the same time. That makes it extremely powerful for graphics, because rendering images requires huge numbers of calculations happening in parallel. But what if that same parallel power could be used for other problems? Scientific computing, simulations, medical research, physics, data processing, and eventually artificial intelligence. The problem was that most programmers did not know how to use GPUs for general computing. The hardware was powerful, but difficult to access. So NVIDIA built CUDA. CUDA was a software platform that allowed developers to program NVIDIA GPUs for tasks beyond graphics. This was not an obvious business decision. It required major investment. It required convincing developers to learn a new way of programming. And for years, it was not clear whether the payoff would ever justify the cost. To many outsiders, NVIDIA was still a gaming company, but Jensen Huang was trying to turn it into something much bigger, a computing platform company. That difference is crucial. A chip company sells chips. A platform company builds an ecosystem. It gives developers tools. It creates habits. It makes customers dependent not just on the hardware, but on the software, libraries, and workflows around the hardware. CUDA became NVIDIA's moat. At first, it was useful for researchers and scientists who needed parallel computing, but the world still had not reached the moment when that capability would become central to the global economy. That moment arrived in 2012. At the University of Toronto, researchers Alex Krzyzewski, Ilya Sutskever, and Jeffrey Hinton built a neural network called AlexNet. It competed in the ImageNet Image Recognition Challenge, and it changed the direction of artificial intelligence. AlexNet did not win by a small margin. It showed that deep neural networks trained with enough data and enough computing power could dramatically outperform previous approaches. And what helped make that possible? NVIDIA GPUs. The chips that had been built for video games turned out to be incredibly useful for training neural networks. This was the twist in the story. NVIDIA had not originally set out to dominate AI. It had built graphics processors. Then it had built CUDA because Jensen believed accelerated computing would matter beyond graphics. And when deep learning finally needed massive parallel computation, NVIDIA was already there. The AI world had found its engine, but even then, the transformation did not happen overnight. For years, AI was still not the mainstream business obsession it would later become. NVIDIA invested in data centers, AI hardware, developer tools, and full-stack systems. It built products for researchers, cloud companies, autonomous driving, robotics, and high-performance computing. The company was no longer just asking, how do we make games look better? It was asking what happens when the GPU becomes the engine of modern computing. And then came the generative AI boom. When ChatGPT launched in late 2022, the public suddenly understood that AI was not just a research field, it was a product. It could write, code, answer questions, generate images, and change how people interacted with computers. Behind these models were massive data centers, and inside those data centers were GPUs. Suddenly, every major technology company needed the same thing: more compute, more training capacity, more inference capacity, more accelerated infrastructure. And the company best positioned to supply that demand was NVIDIA. This is where Jensen Huang's decades-long bet began to look almost prophetic. The company that had started with PC graphics was now selling the hardware and software foundation for the AI age. NVIDIA's data center business exploded. Its revenue climbed at a speed that almost did not look real for a company of its size. Its chips became some of the most desired products in the world. Tech CEOs talked about GPU shortages. Cloud providers built enormous AI infrastructure. Startups raised money partly to buy NVIDIA hardware. Nations began thinking about AI compute as a strategic resource. The GPU had become the new oil of the technology economy. And Jensen Huang, the boy who once cleaned toilets in Kentucky, became one of the most powerful people in global business. But the most interesting thing about Huang is that he does not present NVIDIA's success as a smooth master plan. The story is full of wrong turns, near-death moments, and bets that looked irrational for years. The NV one was a failure. The Sega project nearly killed the company. CUDA required massive investment long before it became obvious. AI took decades to mature. And even today, NVIDIA faces competition, regulation, export restrictions, customer concentration risk, and constant pressure to stay ahead. That may be why Jensen's leadership style is so intense. He is known for having many direct reports, avoiding unnecessary management layers, and pushing information to move quickly through the company. Employees have described a culture of high standards and direct communication. Jensen wants to know what is really happening, not what has been filtered through bureaucracy. In many companies, success creates comfort. At NVIDIA, success seems to have created even more urgency. That is because Jensen Huang understands something that the early chip industry taught him. Every technological lead is temporary. If NVIDIA misses a major transition, another company can take its place. If customers find cheaper or more efficient alternatives, the market can shift. If AI demand slows, the story can change. If regulators or geopolitics reshape chip access, even the strongest company can be forced to adapt. So NVIDIA keeps moving. From gaming GPUs to CUDA, from CUDA to data centers, from data centers to AI supercomputers, from AI training to inference, from inference to robotics, autonomous machines, digital twins, and what Jensen calls AI factories. This is why the story of Jensen Huang is not simply a rags-to-riches story. It is not just about an immigrant becoming a billionaire. It is about a founder who built a company around one core belief: that general-purpose computing would not be enough for the future. For decades, the computer industry was dominated by the CPU. The CPU was the brain of the computer, but NVIDIA argued that a new kind of computing was needed: accelerated computing, where specialized processors handle the workloads that CPUs cannot efficiently manage alone. At first, that meant graphics. Then it meant scientific computing. Then it meant deep learning. Now it means artificial intelligence at global scale. And the remarkable thing is that each stage built on the one before it. Without gaming, NVIDIA might never have built such powerful GPUs. Without GPUs, CUDA would not have mattered. Without CUDA, researchers would have had a harder time using NVIDIA chips for deep learning. Without deep learning, NVIDIA might never have become central to AI. And without the pain of almost dying in the 1990s, Jensen Huang might never have built a company paranoid enough to survive long enough for all of those bets to connect. That is the real business lesson. Most companies want to be early to a trend. NVIDIA was early to a trend before the trend even had a clear name. It built the tools. It waited through years of uncertainty. It kept investing. And when the market finally arrived, NVIDIA was not just participating in the AI boom, it was powering it. By 2026, NVIDIA was reporting annual revenue of more than $200 billion, driven overwhelmingly by demand for data center and AI infrastructure. A company that once feared missing payroll had become a central supplier to the most important technology race in the world. And Jensen Huang's public image had transformed with it. To gamers, NVIDIA had long been familiar. But to the broader world, Jensen became the face of the AI hardware age. The leather jacket, the keynote presentations, the calm confidence, they became part of the mythology. But underneath the mythology is a much harsher story. A child sent across the world before he fully understood why. A student who had to learn English and adapt. A young worker cleaning bathrooms and washing dishes. An engineer studying at night. A founder making the wrong technical bet. A CEO laying off employees to keep the company alive. A company saved by a customer's unexpected generosity. A platform built years before the world knew it needed one. And finally, a moment when the world changed and the company was ready. That is why Jensen Huang's story is so powerful. Because in hindsight, NVIDIA's rise can look inevitable. Of course GPUs mattered. Of course AI needed parallel computing. Of course CUDA became important. Of course NVIDIA became the center of the AI boom. But none of it was obvious at the time. At the beginning, NVIDIA was just 3 founders in a Denny's booth, betting that computers would become visual. Then it was a failing startup, betting on the wrong shape. Then it was a gaming company, betting that graphics processors could become more than graphics processors. Then it was a platform company, betting that developers would learn to use GPUs for computing. Then it was an AI infrastructure company, betting that accelerated computing would reshape the world. And through every version of the company, Jensen Huang remained at the center. Not as a founder who stepped aside once the company became large, not as a visionary who only gave speeches, but as an operator, engineer, salesman, strategist, and cultural force. He built NVIDIA like a company that had already almost died once and never forgot it. And maybe that is the simplest way to understand him. Jensen Huang did not build NVIDIA because everything went right. He built NVIDIA because when things went wrong, he changed direction fast enough to survive, and then made sure, and then kept going long enough for the future to catch up. And when it finally did, NVIDIA was no longer just building chips. It was powering the next era of technology. This was Painted Business Stories. Subscribe for more stories about the risks, failures, and breakthroughs behind the world's most remarkable companies.